All right, everybody. We're using this book, A Systems Approach by Peterson and Davey. And you can log on online and check it out. What we're going to talk about today is mostly switching. We've been mostly talking about directly connecting two computer devices together. But sooner or later, you're going to want to communicate with a machine or a device that's a little further away from you because not all devices are directly connected. And so you'll want to communicate with something a little further away. Switches introduce that kind of second layer ability to talk to machines that are further away from you. In general, they provide this star topology, and you can see this in our book here. But they can also connect to other switches, and those switches then can connect to other switches. Now, this can happen such that these switches are connected in a cycle, and that introduces a variety of issues and problems that we have to deal with. But before we talk about that a little bit, let's talk about kind of the general idea behind how switches kind of form this network and how that's used. You might ask, why do we need a network layer if we can do all this stuff with switches? And the answer is because we want to connect a whole bunch of different types of technologies. Different people are going to own different technologies, and so there's more that we need to do that is actually more beneficial than just switching everything together, and that causes a need for this network layer. But it is possible to form a complete network at layer 2 just with switches, and you can kind of see one built here. The kind of ideas that you need to build a network at this layer extend up to the network layer as well, and so learning some of these things is not a bad idea. So, for example, let's say host A wanted to talk to host E. We have to figure out this pathway through this network such that that can happen. And one way that it can exist is if every switch knows where every host is. And so when A sends a message, um, a datagram, when host A sends a datagram and switch 1 sees it, it will say, hey, I know host E is somewhere to my right. I'm going to send that out port 1. And then switch 2 will get it, and switch 2 will say, hey, I know host E is at my port 2, so I'm going to send it up that way. And this is called a forwarding table. Again, this does exist in networks, like at the network layer as well. Um, but you can imagine kind of every switch has to know where every host is so that it can forward datagrams along to the appropriate place. And this is kind of how you build a network by hand at this level. But what's really, really cool is that you can do other things. So that's kind of the way that our network layer works right now. But you might, when host A wants to talk to host B, you might form what's called a virtual circuit. And basically, the idea is when switch 1 first hears that A wants to talk to B, it kind of sets up a little forwarding table that it's going to use for that connection. So the first time through, switch one, switch 1 sets up like its own little connection for A and B, and then switch 2 hears about it, and it's like, okay, I'll connect this up, and so you establish a connection through the switches, and then you kind of come back through that. It could be a separate connection, or it could be a separate like pipeline or process wave through. And this is another thing that you can do kind of at the at this link level. You typically don't do this at the network level. This is typically done kind of down here. And so this virtual circuit switching is super cool. There are other things that you can do too. Source routing is one of them, but we're going to leave those to another time to kind of keep this video a little bit tight. So let's switch over here to section 3.2 and switch to Ethernet. One of the first things that to talk about in this section is the idea of a learning bridge. And, we talked about Ethernet hubs, and Ethernet hubs are kind of dumb in the sense that they forward all messages that they get kind of back out all ends. But a bridge, the idea behind a bridge is when it's first installed, maybe it doesn't know where anything is. And so instead of having a human kind of go in and say, hey, A, B, and C is out port 1 and XYZ is out port 2, instead this bridge kind of learns where all of these things are. Now, it would have to have a protocol where the protocol says, hey, everybody, tell me if you exist on this network, or they'd have to have some way of communicating that they exist. And then over time, it would build this forwarding table by learning. Now, again, this has its own issues, especially when you have these loops that might exist inside your Ethernet bridges. And we're getting to the point where we want to talk about routing, but you don't really do that until you quite hit the network layer, or at least I try to make that distinction for myself. But what you're really doing here is trying to figure out like what kind of tree structure allows me to touch everything and learn everything. And minimal spanning trees might be something you've heard about in algorithms or something like that before. But ultimately, a router, something this looped network structure of either switched Ethernet or switched routers, I mean, we'll have to learn where all of these things are and then produce a minimal spanning tree to kind of make sure that packets go out where they need to go. So this is super cool. Of course, one way to do this is to avoid the loops. But if you're going to have a network at kind of the network layer, these loops are going to exist because everybody wants to be connected to everybody. And that necessarily kind of pushes loops into the situation. This is a good, very simple graph that shows the difference between a graph and a corresponding spanning tree. And basically, the difference is that there are no cycles, right? It's the difference between a graph and a tree. A tree, you can start at one root node and reach everywhere without ever seeing a second node twice, whereas a graph can have all these cycles and stuff in it. And so there are plenty of these spanning tree algorithms that exist out there. And there's plenty of minimal spanning tree algorithms that exist out there. So the idea is to take a network topology that has loops in it and produce one without loops in it. Super cool stuff. So you can see these links are kind of temporarily dead. Now what happens is if one of these, bridges go down, it's possible that this spanning tree algorithm can rethink and say, you know what, my connection to S5 went down, but I can still communicate with S3 through some other port or something like that. Or maybe S2 goes down. Maybe that's a better one. S2 goes down and I can still reach S3 if I just kind of regrow my spanning tree through S5. And so these routers, and in this case, these switches, they're responsible for kind of constantly communicating, figuring out like which path is the best path. And that allows humans to kind of step away, at least at that lowest level, to step away from kind of building those spanning tree algorithms themselves, which is super good because humans make mistakes. Not that machines can't make mistakes too. Okay, I think I'm gonna call it there. There's the switch algorithms. If you look at I won't bring it up here because I don't know exactly where it is in the book. If you look at the header that has to grow from the frames that exist in this kind of networked environment, they get kind of big. They have lots of addresses in them. You have a source and a destination address, but then you also have hops in the middle. You have kind of like your last source and your next destination kind of tucked in there too. So the header's starting to get a little bit bigger as you grow this kind of link, this layer 2 network link in. Okay, we'll call it there. All of this stuff is very, very cool, and we're approaching the point where we can talk about the really cool stuff, in my opinion, which is the network layer. So that's it for me for this time. See you all next time. Bye. Take care of yourselves.